Hello everyone, Mr. Hissner here, and today we're going to be looking at chords and arcs and some congruencies between the two. So let's just jump into some notes here. So we have chords and arcs, and there are there's two conditions to congruent chords. So we have two chords are congruent, if and only if. So it's a biconditional statement. We need two things to be true. Number one, we need the measures of these. So these two chords, this is a chord. AB is a chord. Oh, hold up. Let me define chords. I don't think we defined chord. Okay, so a chord, let me just define this over here. So chord, it would look like, here's my circle, like this, AB. So a chord is a segment with endpoints on the circle. This is a segment with endpoints on the circle. Okay, so that's what a chord is, and so two chords can be parallel. They are congruent, rather. These two segments that are connecting these their endpoints on the edges of the circle. So what needs to be true is that the chords will be equal if and only if. So if and only if, this is a biconditional statement, the measure of the arcs is the same. The measure of the arcs are equal. So that was the degree measure. So for example, let's say if this chord is 40 degrees, right, from like here, I guess it would be more. And this one would also have to be 40. So we got that. We also have a second condition, B. We have that these are equidistant from the center. These are equidistant from center. So in this figure over here, we would have AB are the same measure as CD if and only if EF. So from the center to the chord is equal to EG, from the center to the other chord. So these two chords will be equidistant if and only if these two green segments are the same. So what does this mean? So for these two chords to be the same, we need these two measures to be the same, which will result in these two chords being the same, and then we know that these two arcs will be the same measure. One thing that you see here as well is we have some perpendiculars. Okay, so if this perpendicular, if AB is perpendicular to the radius, then so if the radius is a perpendicular bisector, then the radius is a perpendicular bisector. So if we have a perpendicular angle, if 90-degree angle is formed by these two lines, then that means that either side of this chord will be the same. Long story short is, we have a lot of sameness whenever we're dealing with these figures. So if we look at number one, this one just jumps right out of us. It says find x. So we know that these two measures, central angle measures, will be the same. So simply just set up a nice little equality here and just get on with your life. Let's see what the next one is. It's like, oh, okay. Well, these tell us that these two arc measures are the same, but they're telling us that these two segments we need to somehow find. Well, if we go back up here, it says if the arc measures are the same, then the segments will be the same as well. So again, for this one, just simply set up an equation. Solve for x, and then we want to plug it back into to xy. So just some simple subtract from both sides, right? Minus 4x, minus 4x. I guess it's been a while since we did this, so plus 34. We want to do the same thing to both sides. So here we have 5x, not 5xx. 5x is equal to 35. Divide both sides by 5. We find x is 7, and this is 4 times x plus 1, so that's going to be a 21. So just some reminder of how algebra works. Not that most of us need to be reminded. Let's look at something else. How about we look at number 6? Because number 6 has some perpendicular things going on here. Okay, so number 6 says we have these perpendicular lines, right? We're told that MP is 5x minus 34, and we're still PN is 2x minus 4. Find MP. Find MP. And you might be thinking like, whoa, what's going on here? But we need to use the language. The language says that if the chord is perpendicular to the radius, then the radius is a perpendicular bisector. Oh no, that's not the one. It's this one. It is the chords are equidistant from the center. So if the chords are congruent, then they will be equidistant to the center. So that means, okay, let's see. We got a couple layers going on here. We have the angle measures here. Central angle measures are the same, which implies that the chords are the same, which then would imply that the chords are then equidistant from the center. So for this figure, it's the arc measures are the same, so the chords are the same. If the chords are the same, then they're equidistant from the center, so these two segments would be the same. This is if A is equal to B and B is equal to C, then A implies C. So here we got this transitive property happening through that chain of events. Luckily for us, this is a very simple equation to set up. And then just throw it back on into MP. All right, guys, this is really the basic thing. A lot of figuring out these chords is not very difficult. We just have to read the notes carefully and kind of stick to these very well. Thanks for watching, guys.